Right. All right. Hello, everybody. My name is Sarah McAnulty. I run the Skype a Scientist program. I'm so excited to have you all here on this lovely Tuesday morning / afternoon to talk about robots. Today, like all of our sessions, are all question and answer. So we'll do a brief introduction where our scientist for the day, Nick, will be telling us who he is, what he does, why he likes it. And then this whole conversation is based on what you are curious about. So feel free to submit questions as soon as you'd like into the Q&A function at the bottom of your screen. There should be two little speech bubbles with a Q&A underneath. Type your questions in there and we will get to as many of them as we humanly possibly can in the next 45 minutes. Nick, thank you so much for taking the time to talk with us.
Yeah, thank you for having me.
Of course. Would you like to give us a little bit of background about who you are, what you do, and why you like it?
Yeah, and I'll start with my PhD because I feel like that's kind of where robots began for me. So I went to the University of Pittsburgh, did my bachelor's, master's, PhD. Sometime around my master's, my PhD, I started getting into control systems and dynamics. So studying the motion of objects and how we control them. And so through that, I wanted to do a master's or a PhD. I wanted to go on, potentially teach at a university, although that's not the direction that I ended up taking. And so I went into my PhD and I did research in neuroprosthetics for paraplegics. So what we were doing was actually studying how we could help persons with disability, specifically motor function disability, like paraplegia, to enable them to use their muscles to actually walk again. And so a lot of what we were doing, was simulated work, robotics, and I think that's where it didn't feel like robotics at the time, right? But that is where I would kind of label it as being robotics. So studying the dynamics of walking, how we control motor function to inhibit or actually cause the walking motion. And for my PhD, I went and I joined up with a small startup company doing robotics. And so my robotics career, I would say, began when I joined up with IM Robotics. That was 2016. The 8th person hired at the time. They were working out of a garage. So it really was a startup company. Got to be with them for about 6-7 years working on mobile manipulation platforms for logistics operations. So we were developing robots to help with piece picking in warehouses.
Okay.
Had a few other projects that we developed with them. And then just last year, actually, left IM Robotics to go to RE², which was shortly after acquired by Sarcos Robotics. And I'm currently with Sarcos Robotics, again, back on exoskeletons, not for paraplegics now, but for industrial use.
What is like an example of an exoskeleton that would be used for industrial stuff?
Yeah, so usually exoskeletons are meant to either give the human operator more strength or more endurance. So sometimes you'll see exoskeletons in applications where they're very simple, right? They might just be helping you bend and lift at the waist. So helping you with hip flexion, knee extension, so that you think about people that are working in warehouses, their job is to pick up heavy boxes and move them around. And there's regulations around how heavy those boxes can be, but those regulations are 30, 40 pound boxes. So you're spending an 8-hour workday lifting up, putting down 30, 40 pound boxes. So some exoskeletons get used in applications like that, where they help to prevent injuries. They allow you to do your work more efficiently. And then other applications, where Sarcos's exoskeleton tends to specialize in heavy lifts. So the exoskeleton with an operator in it can lift up to 200 pounds for a very short period of time. And to you, the operator, it feels like only a few pounds.
That's pretty cool.
So the idea there is that you have some work environments where you do have these large, heavy objects, and you're in sort of a strange environment where it's a little bit constrained, and things like cranes may not fit in the place. So you may not have other abilities to lift those objects.
So should I be picturing, so I don't know if you've seen the latest Avatar movie, but there's like the woman from The Sopranos, Tony Soprano's wife, is in a like robot, basically like not quite an Optimus Prime, but like she's in a robot walking around. Is this the kind of thing I should be picturing, or is it like more clothing like intensity visually? You know what I mean?
It's in between.
Okay.
Size wise, I feel like it's close to, what was the Tom Cruise movie where he kept going back in time?
Oh, Live, Die, Repeat.
No, maybe. I can see it in my mind, but it's a little bit bigger than clothing, right?
Okay.
Some of these actuators are designed to lift 200 pounds. A robotic manipulator that's about the size of your arm usually is going to be lifting somewhere in the 20-pound range. So you can imagine how much larger the actuator and the manipulator needs to be to scale up to 100, 200 pounds, right? Not as big as the ones in Avatar, but big.
But big. You don't have any pictures of this stuff, do you?
I would recommend going to the website. The pictures are all up on the website. I would check that out for sure. Cool. So they'll show a few different angles. You'll actually be able to see what it looks like. So with the batteries and everything in it, it's around 300 pounds itself. So it's big, it's heavy.
Cool.
But that's part of the challenge,
Yeah. All right. So I'm going to start. We've got 23 questions in here so far. So I'm going to start ripping through those. And while you're answering questions, I'm going to go find the website and put it in the chat. What is the website called exactly?
Sarcos.com.
Great. Okay. So the first is from Mrs. Cooper's third grade class from Soleil. How do you program robots to talk?
Oh man, that's not an area of expertise for me. I don't program the robots to speak, but I would say it kind of depends on what the application is. If all you need the robot to do is to speak a known word, it's easy, right? It's just like playing a song. You have a track, which is those words, and you just play those tracks. It gets so much more complex when you're looking at natural language and getting to a point of, speaking to your Amazon Echo or your Google devices, right? Or Siri. When they respond back to you, it sounds so natural. And it's much more complex than just playing back one single track.
For sure. Cool. Thank you. The next is from Mr. Bitz's class from Aja. What is the most useful thing you have ever built, in your opinion?
Sorry about that. Can you repeat that?
Sure. From Aja, what is the most useful thing you've ever built, in your opinion?
I'd like to say that the most useful thing was actually the exoskeleton for paraplegics. But really, to me, it didn't really get to the point of being a product. Building something in a lab is a good start, but if you can't get it to the point where it's in the hands of a user changing someone's life, to me, it doesn't really have a lot of value to it. The theory is great. It looks really nice, but until you have people using it, there's no value. Right. I liked what I was doing in IM Robotics. I think we've all heard the stories from Amazon warehouses, just very terrible working conditions. It really, what it comes down to, right, is that some of the work that they do is hard to automate. There's so much automation in logistics operations nowadays that, that is what allows you to get a package when you order it on Amazon and it arrives in 2 days. It's all of that automation. Things run so smoothly. In the cases where they can't automate work, they use manual labor. And in the event of manual labor, right, you end up in a situation like Amazon where it's just a very unhealthy work environment. So to me, seeing all those reports coming out about Amazon and thinking that we're developing automation solutions to help those individuals in bad working conditions, that was rewarding to me. And when I came to RE², which was then acquired by Sarcos, they held a lot of the same beliefs. The goal is to pull people out of dangerous work environments and replace that with a robot, replace it with automation, so that those people can go do better work, more meaningful work.
Totally. That's really great. Thanks. Okay, so we've got a couple questions that are all kind of around the same thing. And that is like, how do you program a robot? Are you using a platform like MATLAB? Are you programming in R? Like, what languages are you using to program these machines?
Yeah, I'd say that MATLAB is pretty common, pretty popular, more so in the simulation and control systems world. Once you get into other applications, there's other more popular programming languages. The two biggest ones in robotics are Python and C++. Those are the most popular languages. You do have some less common programming languages that gets used. I haven't used R for programming robotics, but I have heard of other companies that do use it.
I always just think of R because I come from like the ecology world where R is like the thing we use the most.
Yeah.
Yeah.
So yeah, C++, Python, and it ends up being a lot of code. The autonomous mobile robots that we were building at IM Robotics, specifically the ones that were used in mobile manipulation for piece picking applications, I did count up all of the lines of functional code, so not including any comments, empty lines, anything. And it came out to around 500,000 lines.
Whoa.
So very complex systems require a lot of software. Sometimes the complexity gets kind of pulled away into libraries. You think about the robotics operating system, or ROS, is very common in the robotics world, and they are an open source community who develops the open source robotics operating system, and they have a lot of libraries that make doing some of the complex things a lot easier, right? You don't have to write all of it yourself. Some of it just exists.
What does it mean for software to be open source?
Yeah, I think it would depend on the license, right? There's different licenses that are applied to software. I forget what the ROS license is specifically, but in general, open source means it's open to use for the public for any purpose. They're not going to come asking for you to pay them if you use their open source software in your platform. Again, like I said, it does depend on the library, the license of that open source software. So I'll caution anyone that might actually be looking at using open source and to check the license first.
Right. Cool.
Yeah.
Very good. So how much of your day is spent like putting pieces of metal together to make a robot, and how much of it is spent like programming what the robot's going to do?
Yeah. Well, the amount of time putting something together physically has dropped significantly to almost zero, I'd say. Part of the reason for that is that the team that I work with developing the exoskeleton platform is actually located in Salt Lake City, and that's where all of the hardware is located. So Sarcos, the company that acquired RE² Robotics, they're headquartered in Salt Lake City. So all the hardware for the project that I'm working on is in Salt Lake City. Sometimes I get to get my hands on some actual hardware in Pittsburgh, where we have some of our other projects ongoing. But even that is a little bit rare because I'm not specifically allocated for working on that. I think it's a bit of a misconception that if you get into robotics, You have to know electrical engineering, mechanical engineering, computer science, that you have to be kind of a jack of all trades. And that's definitely not true. I recommend to everyone, right, that you should go in and you should specialize, because if I'm looking for someone to put together the hardware to build a robot, I'm going to find a mechanical engineer and an electrical engineer that do those things 40 hours a week, 100% of their time. And they've done it for years, right? They're very, very good at it because they're specialized. In comparison to, here's a software developer that knows how to, build a CAD model and knows how to go into the machine shop and make something. It's very different. So generally in an organization, you have people that are doing the hardware development, mechanical and electrical engineers, and then you have the individuals who are doing the software development. And sometimes, my degrees are all mechanical engineering. So as someone that spends a lot of time in software, it seems strange, but I don't get a lot of time on the hardware.
Right. Sounds good. Jasmine from Mrs. Cooper's 3rd grade class would like to know, can you program a robot to swim in the water?
Oh, yeah, actually, we have underwater robots as a part of the organization, Sarcos. If you go to the website and look under our products, the branding is still Sapien C class. And so it is an underwater robot with 2 manipulators. The manipulators are intended to mimic the human upper extremities, so that you can manipulate objects underwater that a person might manipulate. So now it's a little bit different, right? It's not swimming like you and I swim. Instead, it's an underwater vehicle, but the functionality of it can be programmed to be autonomous in terms of how it navigates the water, how it swims through the water, and how it manipulates objects with its arms.
Sounds good. Thanks. Our next question is from Jaden from Mr. Bitz's class. What is the biggest project you've ever done? And you can define that however you'd like, but I definitely would want to know what's the biggest robot you've ever made.
Biggest in size, or
Sure. Let's do like biggest robot in size. What's the biggest robot you've worked on?
Yeah. I mean, I'm impressed with a lot of the things that Sarcos has historically developed. The Exo is probably the biggest, and that's the exoskeleton. It has 24 degrees of freedom, so it's a lot more complex than just a robot manipulator. And the autonomous mobile robots, the wheeled robots that we developed at Robotics, it's a little bit easier when you're driving around on wheels than it is when you're in an exoskeleton trying to basically assist with human motion, right? It's much more dynamically complex. In terms of scale of problem, though, the logistics robotics is actually the biggest scale. And the reason for that is in that application, we're not just trying to sell a robot. The goal is actually to sell an entire fleet of robots. As a result of that, it's not just about having one robot and all of the software on that one robot. It's about having 10, 20, 100 robots, and then all of the software to manage and control the entire fleet of robots. So, there's so much software. I mentioned before that it was around a 500,000 lines of code on the robot. It's just as much code off of the robot.
Cool. Sounds good. Our next question. So once we asked if robots can swim, many folks all at the same time asked, can robots fly?
Yes, it goes back to the definition of, what is a robot. And so you can think of quadcopters, right, as basically being robotics. So when you go out and you buy, right, DJI makes very good drones. And a lot of those drones now are actually built with autonomous functionality. So when you're flying that drone, they'll do things like object recognition, detect obstacles, and then fly around them, right? Or some of them can actually be programmed to follow systems. So, sorry, give me 1 second here.
Sure. All right. There are so many good questions here. We're going to get through as many as we possibly can, but there are 108. I can guarantee we're not going to get through 108. But folks at home, if you find that you have a group of people in your room right now that are very curious and could fill an hour or a half hour all by yourselves with your questions, keep in mind, you can always have a scientist just for your group. That's for free, just like these sessions. And you can sign up to get matched with a scientist at skypeascientist.com, just like you signed up for this session too. So if you've got a lot of curiosity brimming from your class, don't hesitate to get a match. We're always available to match you with scientists. Always good to go. And the other nice thing about that, getting a match for just your class, is that if you have learners who are younger or more advanced, you can really target those questions and answers to your group in these live sessions. We love having so many of you here. It's awesome. We get questions that are simpler and more complex all at the same time. And it's of course easier to schedule, but if you want something a little more tailored to you, you can certainly do that. Sometimes in these sessions, when our scientist goes away, I'm able to answer some of the questions. Like if we're having a session about snakes or something, I sometimes know the answer. I don't know enough about robots to answer any of these. So we're gonna have to hang tough. I like this question that we've got from anonymous attendee that's pulling Jasmine in. Are there any robots that can do sign language? I don't know.
You want me to answer, or
if you know the answer, you can answer, sure.
I don't know. It's mostly just like machine learning, I think, where they're having like things like a Google Translate for ASL that people are trying to develop in real time. It's still in process, but robots that actually know sign language, I'm not sure, but it would be cool. There's a lot of very, very like specific hand movements and differences in hand movements that are going to be a little more difficult to do, and like different regional signs, and then different language signs. But I think there must be something that's being researched right now. But I know in like machine learning for like apps that there's like research going on for that.
Cool. Well, thanks for knowing the answer. That's cool.
Yeah.
Awesome. Hey, Nick. All right. We were talking about robots and ASL, the combo of the two. All right. So we've got a question about how a human and a robot can sort of interact. So how does a person's brain connect to what you build for them? I think in the case of the paraplegic robots.
Yeah, for that application, we weren't doing, generally it's called a brain-machine interface. BMI. In that application, we weren't using any brain machine interface. So we weren't interpreting their intent. Right. It's really hard to measure what a person is thinking. There's a few techniques that people are working in research, but they don't have them working in application yet. Actually, at the University of Pittsburgh, I think they've probably got one of the best working systems in terms of a brain-machine interface. They've done a considerable number of experiments, even getting it approved for human research. And they actually had a brain implant into a quadriplegic. So the individual was controlling a robotic arm with their thoughts. It's a lot of work, right? So you're actually taking electrodes and implanting it into a person's brain. Or in the case of someone who is a paraplegic, you can go in at the spinal cord and measure those signals. But it's a lot of work. It's a big operation, so that's why it's not generally done. Like I said, there are a lot of people that in research are trying to do this. For the exoskeleton, like the Guardian Exo from Sarcos, instead of requiring someone actually have some surgical operation or an implant, what we do is we measure their interaction forces with the exoskeleton. So on the handles where they would grip, or on the feet where their feet are attached, we actually have sensors that measure forces and torques at that point. And then we use that to essentially interpret their desired motion.
Cool. We've had a number of questions that are all kind of around the same thing. Again, this is about how, if you are in, let's say, middle school, like what should you be doing to get a career in robotics? What opportunities exist? What classes should you be thinking about taking in the future? How do you make a career in robotics happen?
Yeah. And there's a lot of paths that you can take, right? I mentioned that there's the hardware side, the mechanical and electrical, and then there's also the software side. The first thing that I would recommend is the FIRST robotics program. That has always been one of my favorites, especially in the middle school. You have the option of starting out in FIRST Lego League, and then that program grows as you go on. So, you may not have, as a part of your curriculum through middle school or high school, an actual robotics class. Not everyone's going to offer it. A lot of the core concepts come through mathematics, right? That's a good place to start. Physics, those courses, as many of them as you can take. But in terms of the application and getting some hands-on experience, I definitely recommend getting involved in those robotics competitions.
Great, thank you. Okay, our next question is, what is the range of cost for making a robot? Like, what's the cheapest robot we can make? What's the most expensive robot we can make?
Well, again, it kind of depends on what you think of as a robot and how you define it. If a robot is just generically defined as some autonomous process, then a piece of software is good enough, right? And that's going to be about as cheap as it gets, right? So when you think about things like chatbots, if you qualify a chatbot as a robot, which I would, then that is about as cheap as it gets in terms of production, right? Because you write the software for it, and then it kind of becomes infinitely replicable. Once you get into hardware, right, it starts to get very expensive. And it depends on what you're trying to do, right? The bigger the application, usually the more expensive it's going to be in terms of the hardware. But also the more specialized the application, the more expensive it's going to be. So generally, once you can mass produce things, cost goes down in terms of the platform. But to build that first one, to build a prototype, something that is truly one of a kind, you're custom building everything, and it can become very expensive. So $100,000, $200,000. I don't know. I'm trying to think who the biggest robotic system might be. Carnegie Mellon's National Robotics Company has had some pretty big systems. And I'm sure that some of those are millions of dollars.
For sure. Yeah. I feel like maybe one of the Mars rovers, if that counts as a robot.
Oh yeah.
Would be that expensive? Yeah.
Yeah. Well, that's very, very specialized. It's one of a kind. Part of the cost of that platform isn't just the platform itself, but it's all of the design, testing, and verification that goes into it. So if you know that something needs to work 99.999% of the time, right? Almost every single time, you're going to very rigorously test it. You're going to have fail safes, right? You're going to have things that are backups to all of your processes. And so you're basically, right, when you're building something like the Mars rover, you don't build one Mars rover. It's more like you built two of them in one, because you're going to have all these fault safe extra things that you built in. Because when you send something that expensive, if it goes down, that's it, right? You think about the millions of dollars that go into developing something like that, you can't have a failure.
Right, exactly. All right, our next question. How long, this is from Mrs. Fox's 6th grade class and from Bluey Williams's class. How long does it take to build, test, and then get a robot to the end user?
Depends on the robot. Obviously, the more complex, the longer it's going to take. There's a few different ways that you tend to go about it. People will often refer to the minimum viable product, right? What is the shortest time, smallest possible thing that you can put together to get it in a customer's hand? If you get down to something that's simple, right, even that is going to take probably around 2 years. The longest item, especially now, with everything that happened with the pandemic and the supply chain shortages, the biggest issue is hardware, and that's the biggest bottleneck. A lot of software development, usually what we do to start off on the software development prior to having any hardware is actually begin in simulation. So we develop the software against some simulation, and we continue to work and develop on that simulation until the hardware becomes available, right? And then you get the hardware, and then you find out that something isn't working or it's not good enough, and you have to redesign. And then it's a month, 2 months, maybe more to redesign that system. And then once you've redesigned it, you order those parts. And then because of all the supply chain shortage issues, you might not see those parts for a few more months. And you can see how that kind of really begins to add up. It's one of the biggest challenges with developing and deploying a robotic system. How do you get it out quickly and get it in the customer's hands quickly when developing the hardware can take such a long time?
For sure. Thanks. A question from McCutcheon Elementary in Chicago. What materials are robots made out of?
It depends on the application. I think that if you're dealing with most robots, right, it's steel, aluminum parts. You'll get special metals or alloys in something, a little more complex like the Mars rover. If you have robotics in medical applications, you have to take into consideration what materials you are allowed to use within a clean room environment. So you end up using plastics in a lot of those applications. And so those are the most common, right? But when you think about the metals, you're mostly thinking about the shell of the robot, what you see on the outside. On the inside, right, all those electronics, those PCBs, the printed circuit boards. There's a lot of them, motor drivers, right? So you have your magnets in your motor drivers, your copper wires that are used in the motors. So a lot of different materials. And in most cases, when you're building a robot, just like when you're writing software, you don't write all of it. Sometimes you're using parts that you buy off the shelf.
Great, thank you. Our next question comes from PS7Q in Elmhurst, New York. Can you program a robot to have feelings?
That probably goes way beyond my understanding of robotics. That gets a little bit more into kind of the philosophy of it. Obviously, there are people that are looking at doing that, and you hear about things like the Turing test, right? How do you know the thing you're talking to is a robot, and at what point do you sort of cross into that realm where it's indiscernible? And then what do you do when you can't tell the difference between a robot and a human, right? When does it become conscious and have feelings and emotions like a human being? That's way beyond what I do.
Sounds good. A bunch of folks have asked, what is your favorite part of your job and your least favorite part of your job?
I think in general, my favorite part of my job is just the problem solving. Taking something very complex, breaking it down into all the small pieces, and determining how to solve a very complex problem. Me also being a manager, I mentioned before that I went to do my PhD. The reason for that was because I did want to teach. That was something that I was interested in because when I was at Pitt, I was a tutor, I was a teacher, I taught summer robotics programs at Pitt. And, academia was not the direction I decided to go, but I found a way to continue to be a teacher, just not in an academic environment. So as a manager, I have the opportunity to teach the people that I manage. And so I continue to do that. And that is something that I enjoy doing. In robotics, because it's such a complex field that requires so many disciplines, I enjoy getting exposed to all of these different disciplines, these different industries that we work in, and learning from the people that I'm around. So it's probably three different things, but those are my favorite things of working in robotics. Least favorite thing. It's a tough one. Because sometimes I feel like what is my least favorite thing about it is really just that it can be very complex. It can be very hard, and sometimes that does get very frustrating and you have to find a way to push through it. Sometimes you're trying to solve problems that no one else has worked on or solved before, which can be exciting, but also very frustrating.
Sounds good. Our next question has come in a couple times as well. Can you make a fireproof robot?
Fireproof. I would imagine that you can make it fireproof to a certain extent, right? And so deploying robotic systems to disaster sites, it is a big research topic. I don't think it's made its way out into application yet. When you think about the incidents, like in Japan, 3 Mile Island, the nuclear fallouts, you can't send people into those environments. And so there are a lot of people that are doing research, and specifically for those disasters, they were able to send robots in to help in those environments. I'm sure that someone out there is trying to figure out, in the event of a fire, how do we get a robot in the building to search for people, to guide firefighters, to help them be better at their jobs and reduce the amount of risk that is that comes from being a firefighter and going into those dangerous environments. So I have not tried to build a fireproof robot, but I am pretty certain that someone is trying.
I bet they are. All right, our next question is from VISII educators. What role does AI play in robotics? Should we be worried about robots taking over the world?
I would say no. I think when it comes to robotics companies that put out videos that scare people, Boston Dynamics is the best. And if you haven't seen their videos, Google Boston Dynamics. They just had a new one that they came out with, where their robot autonomously goes over, picks up a piece of wood, puts it down, runs up a platform, goes across that beam of wood, grabs a tool bag, throws it up to another person, and then does a backflip off of where they're standing. And you see videos like that and you think, wow, that robot can just do everything. That's unbelievable. Fortunately, Boston Dynamics has become so much more honest with their videos that when they release one of those videos, they also release a blooper video. So if you haven't gone to see the blooper video, go see the blooper video. So much work goes into creating that video, creating that demonstration. It takes so many attempts to get it right that I don't think you have to worry about one of their robots, becoming sentient and going out and trying to overthrow the world, right? If you want to throw off a robot, just close a door. It probably can't open it. And that sounds right. That sounds silly. And obviously that's a problem that they're trying to overcome. Because I mentioned disaster relief before, right? If you're sending a robot into a building, you want them to have a lot of the same abilities as a human. You want them to be able to open doors and go into that environment. But there has been some competitions, robotics competitions, where opening the door is a part of the challenge, right? Open the door and walk through it. Usually 1 out of like 10 teams actually gets through that door.
Right. Cool. All right. So a number of questions have asked, let's see. Okay. So they want to make a homemade robot. They want to know, can we make a homemade robot out of recycled materials? Like, what kind of materials could a person at home make a robot out of?
Ooh, yeah. I think if you're trying to deploy a robot with recycled materials, I can't think of any companies that are currently doing that. But there are a lot of robotic systems that use plastics, right? Usually you'll see robotics that have plastic cases on them. I would imagine that to an extent, some of them are using recycled plastic parts. Or if you're at home and you want to build your own robot out of recycled plastic, buy a 3D printer, and then also they do make hardware that you can use to melt down plastic and then make it into a filament that gets used in a 3D printer. So yeah, if you have plastic, you can build a lot of those plastic components at home. The electronics get a little bit trickier. And that's really just because the technology changes so quickly. You think about how often you need a new smartphone, how often you need a new laptop. It becomes a lot more challenging when you're talking about using recycled electronics.
Mm-hmm. Very good. All right. We are pretty much out of time, unfortunately. Oh gosh. Let's ask one more question here. Okay, so when you are designing robots that are going to go on people's bodies, like, how do you figure out how to make a robot that's both very strong, but also like comfortable for people to wear?
Yeah, I mean, there's a whole organization, or at least a committee within an organization that is looking into that. So we tend to use a lot of what the ASTM develops. So there's an ASTM committee who is specifically dedicated to exoskeletons, and within them is a subcommittee on the actual fit of exoskeletons. And they help out a lot. They provide some guidance. Exoskeletons are very tricky because when you think about robotics, you picture rigid, fixed bodies. But the human body is very organic, and it's so different from person to person that developing one generalized fit exoskeleton is a very hard challenge. So usually what we'll do, right, is that we don't design it for 100% of the population because that's impossible.
Right.
We just look statistically at what would be the appropriate size to develop for based on statistics of human populations, height, weight, body segment lengths, those characteristics.
Great. Okay. So now we ask everybody the same 2 questions at the end of every session. The first question is, if you had everyone's attention in the whole world and you could tell them one thing about your area of expertise, what would you tell them?
Oh man, that is such a hard question. I wish I had prepared. I mean, I think I would probably go back to what I said before about if you want to get into robotics, you don't have to be able to do it all. There are people that view robotics as kind of this impossible field to get into because if you don't have a degree in mechanical engineering and electrical engineering, computer science, right, if you can't do it all, then there's no point in going into robotics. That's actually not true at all. In fact, if you don't want to go into the engineering side of robotics, you don't have to. The organization chart of a robotics company has all the same functions of every other company. So you have people working in sales, you have people working in marketing, you have people that are doing, UI development, UX development. You've got people that are doing, directing the actual applications. So you've got systems engineers who are working that aren't, they're not writing code, they're not working with hardware, but they have a very important job function. And so to me, yeah, people look at robotics companies or people think about a career in robotics and they think, I need to know everything. The reality is that you don't. It helps if you know a little bit about it. So I think the breadth of your knowledge is important, just not necessarily depth in all categories. So like I mentioned before, because it does require skills, you're going to work with a very diverse group of people. You need to be able to communicate with them. So you have to understand their background, their job to a certain degree.
Great. All right. Our final question for the day. You still have everyone's attention in the world, and you can tell them one thing about anything. It could be about your area of expertise. It could be significant and important for the world. It could be like, mounds are better than almond joy. Whatever you would like to say.
Oh, man. Save the hard questions for the end.
That's true.
Yeah. Anything not necessarily field related. I think at least one of the things that I've personally been dealing with a lot, and especially because I'm in engineering, is that I will tell everyone on the call, work on your soft skills. They are so important. Another thing that I do with University of Pittsburgh is that I volunteer as an Alumni-In-Residence. So I work with the Career Center and I consult with students in terms of their career development. And one of the big things that comes up, people in engineering are like, what skills do I have to develop? What do I have to learn? And they take all these math classes, these physics classes, they take all their engineering classes and they think, okay, I'm ready to go. I'm ready to get into the field. And then you go and you work with all these people from these diverse backgrounds and different degrees and disciplines, and you just don't know how to communicate with them. Right? You're very technically skilled, but you don't have those soft skills. And it's a thing that I've found in the career consulting work that I've been doing is developing those soft skills is incredibly important, because the only way that we solve some of these really big challenging problems is as a team.
Yeah.
There's a lot of these big challenging problems that you yourself will not solve. It's going to require a lot of people. You think about how big some of these companies are. Sarcos, after the acquisition, is around 300 people. So it's not one person trying to build an exoskeleton for industrial applications. It's 300 people working together to build an exoskeleton. And if you don't have those soft skills, you will never achieve that goal.
Sounds good. That's really good advice. I co-sign that for sure. All right. Thank you for sharing all your knowledge with us today. This was super, super cool. Is there anything else you'd like to plug before we say goodbye?
No, I'm always open to questions. If anyone has any, you guys can find me on LinkedIn. Apparently I'm not the only Nick Kirsch on LinkedIn, so make sure it's the right one first. My name's a lot more common than I thought.
Sounds good.
But no, I'm always open to communicate and try to help people and help people further understand not just robotics, engineering in general. You mentioned that there's a lot of people that have concerns about artificial intelligence, and to a degree, some of those concerns are valid. To me, it's a part of my job to make sure that I'm communicating with people, helping them understand those things, learning to live with and use the technology. So yeah. That's it.
Great. All right, thank you so much. Thank you everybody for coming. This session will be available like all of our sessions at youtube.com/Skype a Scientist if you have anybody that you'd like to share this session with. And we'll see you next time. Jasmine, thank you for signing. We really appreciate it. All right, see you next time, everybody. Bye.
Bye. Thank you for having me.
Thanks.